This question is from GATE 2022 Mechanical Engineering paper set 1, question number 31. The plane of the figure represents a horizontal plane. A thin rigid rod at rest is pivoted without friction about a fixed critical axis passing through point O. Its mass moment of inertia is equal to 0.1 kg centimeter square about O. A point mass of 0.001 kg hits it normally at 200 cm per second at the location shown and sticks to it. Immediately after the impact, the angular velocity of the rod is dash radians per second in integer. Let's find out. So we'll start by writing the given things first. Mass moment of inertia of the rod I about point O is given to be 0.1 kg centimeter square. Mass M is given to be 0.001 kg, which is going to travel upwards and stick to the rod on the left end. Also, this distance we can denote by R is given as 10 centimeter, and velocity of the mass is given to be 200 centimeter per second. Now when this mass will travel upwards and stick here on the rod, its axis of rotation will become same as the axis of rotation of the rod, and we need to find out the modified mass moment of inertia of the combined system with the mass and the rod. So for doing that, we will calculate I about O, but for mass M plus rod. Mass M and rod. It is actually not an addition operation. It is showing that it is for mass and the rod. So this will be equal to mass moment of inertia I naught of the rod itself. So 0.1 plus the mass into the distance square from the point O. Because when the mass sticks here, its distance from point O is remaining same, which is 10 centimeter. So we can use the parallel axis theorems. Axis of the mass is here and axis of the rotational system is at point O. So we can do it 0.001 kg is the mass into distance square. Distance between point O and the mass is 10 centimeter. So we can write here it's 10 square. We keep all the units same because I is given in kg centimeter per square. So we can take the distance in centimeter here. This turns out to be 0.1 plus 0.001 into 100, which is 0.1. So this is 0.2 kg centimeter square. Mass moment of inertia of the total system now will be 0.2 kg centimeter square, which will rotate together. Now angular velocity of the rod can be found out using the law of conservation of momentum. So we write using law of conservation of momentum. We have the average momentum of point mass before striking will be equal to the average momentum of point mass after striking. So how do we write it? Linear momentum P bar into the distance R will be equal to this modified mass moment of inertia I naught M and rod into angular velocity omega. On the both sides we can see that angular momentum is written but using different terms. So we need to find omega. Just rearrange. We have omega equal to linear momentum can be written as m into v. So we have m into v into r divided by I naught of mass and rod. Substituting the values, we will have mass is 0.001, velocity is 200 and r is 10 divided by 0.2. So this turns out to be 2 upon 0.2, which is 20 by 2. So it is 10 radian per second. So we have the angular velocity of the rod after the mass strikes it. Let's go back and fill in this answer. Angular velocity of the rod is 10 radians per second. The answer already is in integer form. To learn more about circular motion, you can refer to the NPTEL video Lecture 22 Circular Motion. It's from the course Engineering Mechanics. The course is taught by Professor K. Ramesh. He is from IIT Madras. I hope this solution helps you clear your doubt. Thank you.